near as weird or broken up or confusing. Radicals. Do you guys remember yesterday? There were a few of you. I'm going to get a new page in here. Here we go. There were 2 homework questions on homework number 2. I think they were even numbered number 70 and 72.
Oh,
You guys remember those?
yeah.
And there might be like a 71. I don't know. But 70 was, someone asked me about it yesterday. What's the square root of 25? 5. Nice. And then the other one was a little bit harder. I think, was it a cubed root?
It was a fraction.
Oh, it was a fraction. That's
square
right.
root of 1 over 64. Yeah.
There you go. And it was still a square root. And I think I even showed you the answer, and some of you already know it. This one's answer, if you put it in your calculator or from your classmates right now, is 5. But can I ask you why? Why? Yeah. We could rewrite 25 to be 5 times 5, which was totally perfect, but she also said it's a square root. Now, hold on, square root. Why is it called a square root?
Because it's a square, 5 squared.
Okay, it's 5 squared, and the square root says, who's squared? 5? Cool, that's the answer. But the funny thing is, actually, there is an understood 2. You guys know how sometimes with numbers, and we did this a few times, if we have like a 5, we put it over 1, we can put an understood 1. But we also talked about if you have an expression like 5x squared y cubed, isn't there an understood 1 also in the exponent? So there are some places in math where there's an understood. What if I wrote down an x? What's the understood coefficient in front? 1, right? And technically, if you want me to be super crazy, I could also do something like 3, and there could be an understood 0, but that's really awkward and weird. Doesn't really help much, usually. But in radicals, or in roots, square roots have an understood baby 2, which might not make a big deal to you guys until we start seeing cubed roots and 4th roots and 5th roots. If the radical does not have any number there, it's understood to be a 2, and so we're looking for, hey, what value has been multiplied together this many times to make this number? Now, how could I rewrite, so 5 is squared, and so square root says, hey, give me the 5. This is also a square root, right? It's an understood 2.
Number 8.
Now, why is it 1/8? Couldn't we rewrite? We could write it with lots of 2's, that's totally true. And at 64, we could figure out those 2's. Which one makes more sense? Me doing a factoring tree like this.
Yeah, that's just.
Well, someone just told me that it's a lot of 2's, and I wanted to see how many 2's it was. How many 2's is it? 1, 2, 3, 4, 5, 6. Whew, there's 6 of them. I could do it that way. Some of you might have done factoring this way. I'm doing a lot of dividing. Whew. 2 into 64 is, 2 into 32 is, and I also get 6 2's. But some of you are like, wait, I know 64. 64 is what times what?
8.
So if I'm technically just looking for pairs of things, couldn't we just be like, oh, hey, there's a pair of 8's that are being multiplied? And a pair of 2's that are being multiplied? So yesterday when we answered 1/8, you guys were totally right. And it was because a pair of 1's multiplied to be 1, a pair of 8's multiplied to be 64. But someone did mention it's 2 to the power of 6. Is there another way to do this problem? What if I was to have the understood square root, and what if you didn't realize it was 8 times 8? Maybe the number was way too big. Maybe the number was something like 225. And you're like, uh-oh, I don't know that one. So maybe you would have done something like this with 225 and broken it down to get it to be 5 to lots of powers. So what if we did have, does anybody know 1, 2, 3, 4, 5? How could we have answered this question if we're looking for pairs? What if you didn't know that 64 was 8 squared? And we're looking for pairs. How many pairs of 2's are there?
3.
6 2's. How many pairs?
Three.
Yeah, like if you had 3 pairs of shoes, there are 6 shoes, but only 3 pairs, right? So there are 1, 2, 3 pairs. So guess what the answer would have been? What's 2 times 2 times 2?
8.
So you could have gotten there either way. You're just always looking for pairs because what kind of root or radical is it?
Square.
Square root. So then we come over here into our notes, right? Have any of you guys thought of how to fill in the boxes?
Yeah.
What? Oh, we just talked about this one. 8 ends up being 2 times 2 times 2, or 2 to the power of 3, right? Okay. 81. Okay, it would have been harder for most of your brains to go straight here, but it's nice that they filled this one in for us. So how can we fill in these boxes?
3 times 3.
Yeah. 3 times 3 times 3 times 3. Or 3 to the power of 4. Which, if I showed you 81, how do most of you have 81 memorized as? 81 is what? 9 times 9, or 9 squared. Which would be great if he was under a square root looking for pairs. But in section 6.2, we're going to see radicals, or roots, that aren't just looking for pairs. Maybe they're looking for sets of 4. If they're looking for sets of 4, 9 wouldn't be the answer. 3 would be. What's 25?
9 times 5.
AKA, who's squared? 5. Okay. So from these facts, can I show you what else we can say? From this fact, I can say that the cubed root of 8 is equal to what? Why? What would a cubed root be looking for? If a square root is looking for pairs, a cubed root is going to be looking for sets of 3. So what multiplies 3 times to get 8? 2. And the way you could tell that is rewriting 8 to be 2 times 2 times 2 and say, oh, hey, I see a set of 3, and what is it? Oh, it's 2s. That makes sense. Now, what if I was to ask for the 4th root? Don't worry, these ones, they're going to show you this little number, because a square root is the only understood. If you see a radical with nothing, it says 2. It's a square looking for pairs. But every other radical is going to have to give you, no, I'm looking for 3s now. Okay, fine, looking for 3s. I'm looking for 4s now. So if there's an 81, what would we really want to figure out? That 81 is the same thing as 3 times 3 times 3 times 3. What's the 4th root of 81? 3. Do you see it? And we already did this one. What's the square root of 25? A lot of you knew that it was 5, and you're totally right. But the reason it is because there's an understood 2. And what is 25? So square roots look for pairs. Whose pair? 5. Cubed roots look for sets of 3. Whose set of 3? 2. 4th roots look for sets of 4. Whose set of 4? 3. So we're going to be dealing with radicals, but not just square roots, but also 4th roots, 3rd roots. And you can also say that it is, well, let's go forward a page. Let's go forward a page. So we have some new terminology to talk about. I'm going to try and get out of this. There you go. You guys can't read that, huh? Is the highlighter too dark? Okay. Let me make this highlighter a lot lighter. Yeah, it says nth root, which is really weird. But as you guys were noticing, I was saying a square root. Is that better?
Yeah.
Cool. In algebra, whenever we're trying to talk about something generally and not specifically, we use variables. Can I turn off the light? Is that even better?
Yeah. Oh, that's
Okay, cool. In algebra, when we're trying to be general, or generalize something, we use variables. X can stand for a number. Y can stand for a number. A can stand for a number. So can N. So can N. Nth roots are talking about the type of root might change. So we use the letter N to say, well, whatever you see, let's talk about a general procedure that you can use. If it's a square root, a cubed root, a 4th root, a 5th root, a 6th root, do you guys see why it's N? Square is weird. There's no th on it. 3rd root is weird, but everything after that, 4th, 5th, 6th, 7th, 8. They all have a th. So we're saying nth root being like that can change. That can change. And most of us are used to this. Well, can we label some stuff? Is that okay? Let's label some stuff. Let's go ahead and, do you know how we did it in our little exponent rule book with different colors? If you guys have different colors, now might be a good time, because we're going to label the different names of all the pieces in here. So if you have different colors, a 4-color pen, you can grab that out. If you guys notice on my smartboard, I have black and green, blue and red, so it's the same colors as the 4-color pen. Okay. I'm going to go ahead and label this guy the base. You guys know why I'm labeling him the base?
Because he's inside.
Because he's inside, and what does he end up being when we rewrite him? Well, yeah, you're right, because the radical's gone, right? But isn't this what I called the base before for anything with an exponent? Right? So this guy is the base. The big value underneath is also going to be the base raised to an exponent. This we already know, which a lot of you guys say root. I'm going to call it a radical, though, technically, because it's a radical sign. That's the snazzy name for this symbol. Then we have the n. Then we have the n, which technically we could call. I'm going to circle him, because he's pretty important. I'm just going to put the root. Technically, I think there is a snazzy name for him. I think it's called the index, like an index card. I mean, it doesn't really make sense as to why it's called index by using an index card, but he does have a snazzy name. But I'm going to call him the root because our book says the nth root. But do you guys see how the n is also over here underneath the fraction mark? The root, the little guy that's with the radical, can be rewritten or put in an exponent underneath a fraction bar. I'll kind of rewrite this with words as to how my brain remembers it in just 1 second. But if you guys realize, let's see, we circled the n, circled the n. Let me write the base in blue if you guys don't mind, because the A is the base, he's in blue. What's the one, or actually the two things that don't have a color assigned to them yet? The radical is green, the n is red, the base is
The
blue.
1.
The 1 and the fraction mark, right? Where did that 1 come from? What's anybody's understood power?
1.
Yeah. Anybody's understood power is 1. So where did the 1 come from? He came from the understood power. So actually, he did come from someplace. There's only one other thing that doesn't have a color attached, because now I have the black one.
The 1.
Why am I making this green? Anybody know? It has to do with the radical. Perfect. Now, some of you are like, I don't have colors to color code things. Well, remember, technically on our supply list, supposed to have colors. I think it helps. But also, I told your parents last night, and it's in the email that I sent home. I record my lectures every day, and I save these notes online. We'll talk next week about Google Classroom and whether you guys are in there, because I put little reminders in there. And there are links to my YouTube channel in your folder. You can pull it up in your phone real easy. But colors are good, so even if you don't have them today, you should maybe do them some other time, because this line is because of the radical. This n is because of the root. This base is because of the value inside, and this numerator is because of the exponent. And one of the big things this section is talking about radicals. Isn't that the title of section 6.2? Radicals. And rational exponents. He's an exponent, right, guys? He's my rational exponent. because rational comes from ratio, and ratio means fraction. Rational comes from ratio, and ratio means fraction. So even if you have no idea what kind of problems are going to come in this section, right now we have the entire section titled in this little baby equation, because we have a radical and we have something raised to a rational exponent. So the whole rest of the section is, okay, so what does that mean and how do we use it? What are we supposed to be doing with this radical and this rational exponent? As you guys are writing down your notes, you should come across the word factor pretty quickly, right? What does factor mean? Now actually, factor is a super important word for algebra, and specifically Algebra Semester 2 for Algebra 1AB, or Algebra 1B. Factor is a really important word. Factor is a really, really important word. But it's not just in math. You might hear in other contexts something like, what are the factors? And if you're hearing someone say, what are the factors? What they're basically asking is, okay, there's some problem, there's some situation, something going on, and they're having to analyze it and think about what's going on. What are the factors? What are the contributing factors? What are the pieces or what are the events that led up to something? Technically, we could talk about the factors of a car, which is really weird. But the factors of a car, what are the factors of a car? You almost never hear anyone say it. The engine, the wheels, the steering wheel, the seats, the doors. We could get into the car itself, the alternator, the transmission, the spark plugs, right? Those are the factors of the car. Why? They're the pieces that make it up. What are the factors of a basketball team? The players. Well, what about, well, there's the coaches, there are the referees, there are the courts, there are the hoops, there are the balls, right? But not even just that. Then you have, well, you have like the point guard, and you have like the post players, right? And then you have the guards, and then you have the, okay, we keep on going. The factors of a basketball game, well, there's all kinds of factors, yeah? The factors of a math classroom. Well, it depends on the math classroom, but my classroom, well, there's the computer, there's the smartboard, there are the students, there are the textbooks, there are the notebooks, there are the pencils. What are the factors of a number, though? Well, can we take this number as an example? 64. 64. You guys already figured out. It's 8 times 8. Great, but that's a pair. What kind of root are we looking for? It's really light. It's a third root. We're looking for a third root. Well, wait a minute. 8 is a pair. 8 times 8. And then we did 2. But that was... Wait. Didn't 2 end up being 2 to the power of 6? That doesn't help. So what if we're looking for a set of 3? Well, we got to factor down the number. So how do we factor down 64? Anybody know? Didn't we just do it?
Yeah.
How did I factor 64? Can I ask you guys a quick question? I showed you on the page before a tree, I call it a tree, and I showed you a box method. Because we did just break down 64 a second ago. This is actually called finding the factors, or factoring. So this process was factoring 64, okay? How many of you have seen the factoring tree before? Raise your hand. Okay, that's called the tree method, the factoring tree. How many of you guys have seen the box method? Interesting, we have a little bit of both. Okay. Can you guys look at both of them? Some of you have seen the tree before. Some of you have seen the box before. The tree, we're trying just to figure out 2 numbers that multiply and break them down until, what are the only numbers that go into 2? 1 and 2. So there's nothing else to add. There's no further factoring, no further breaking down into components. What am I doing here, though? I'm not trying to find 2 numbers and 2 numbers and 2 numbers. I'm just saying divide, divide, divide. Can I just see you guys vote? How many of you guys like the tree better? How many of you guys like the box better? We have half and half. Okay, so I'm going to kind of do both of them as we go, just because we have brains that are working differently. That's totally fine. The nice thing is, for this one, we already know what ends up happening. Is that okay? Whether you do the tree or whether you do the box, we know that this ends up finally becoming, you know what, I'll do it. Sorry, I want to show you all the 2's. I put way too many 2's into that guy. Only one 2. Okay, it becomes 2 to the power of 6, right? If I factor A, my 2 disappear. I can say 64 is equal to 2 times 2 times 2 times 2 times 2. Ugh, do I have 6? Yeah. Have I factored A? Yeah, I totally broke them down into smaller pieces. Cool. So now what does number 2 say? Rewrite the radical as an exponent. So I can rewrite the cubed root of 64 as, oh, wait a minute, hold on, no, we just factored A, so it's not 64 anymore. What is this? 2 to the power of, good, 2 to the power of 6. Okay, wait, hold on, help me out. How do I rewrite the radical as, or with, an exponent? What's my base going to be? 2. What's my numerator going to be? Because I steal the exponent, 6. I have my line because there's a radical, and then what's going to be my denominator? N, which is 3. So if it helps, you can always color code it and say, okay, I have my radical, so that's where my line comes from. I have my 6, which is where my numerator came from. I have my 2, and then I have my 3, right? If you want to color code, but you don't have to. But guys, when we rewrite this, here's a question. And is this one a little bit too dark? Is it hard to see? I can rewrite it as 6 over 3. Oh, this is supposed to be red. Why am I saying simplify? Is there anything that you see in here that you can simplify? Yeah, what's 6 over 3?
2 over
So
1.
it'd be 2 to the power of 2 over 1 is just 2, right? Hey guys, what's 2 times 2, or 2 squared?
4.
How is that the answer? We're looking for sets or pairs of 3. Sets of 3. Do you guys see that up here we could have split this up into 2 sets of 3? Who had a set of 3? 2 did. Who had a set of 3? 2 did. What's 2 times 2?
4.
There are a couple different ways of doing it. One way is looking for sets of whatever the root is or whatever the index is, and there were 2 sets of 3. There was a set of 3 for 2 and a set of 3 for 2. So you could have done 2 times 2 just by looking for sets, or you could have rewritten it with a rational exponent and simplified it. Got you to the exact same answer. Now some of you are going to like this method better because it makes more sense. You're looking for sets of 3, sets of 4, sets of 2, sets of 5. You're looking for sets of things. But some of you might like the more mathematical way better, especially if the numbers start getting really, really big. But, long story short, when your section 6.2 says radicals, what's it talking about? These guys. And when your section title says rational exponents, what's it talking about? These guys. Okay, I want you guys to do the following. Ready? One person in every group to come up and grab a baby whiteboard and an expo marker and come back to your seat. Go. Go quick, go quick. We're just going to do a couple sample problems, and some of you guys need to move and need to talk and need to kind of wiggle it out. We have 5 minutes. We can only have time for a couple examples. We're just starting this section today. Go fast, go fast. All right, whoever got it, open your marker. Who's going to be the first? Oh, yours right now? I'm sorry. Here we go. Here's one. Here's one. Here you go. Here's 2. Right on this side. Here's another one. Oh, no. Here you go. All right. My first direction to you. Just right on that. Okay. I just want you to, ready? Rewrite. I just want you to rewrite. And I'm going to say with rational exponents. You don't need to write this down on your board. These are the directions. Remember, only the person with the marker gets to write it down. The rest of the group gets to give them advice. So what if I was to give you, ready? The cubed root of 5 squared. Okay, rewrite. The cubed root of 5 squared. Just rewrite. So you write it down first. Write it down first. The cubed root of 5 squared. Write the problem. I'll give you a hint.
Yes, exactly.
Should be something on top and something on bottom. How would you rewrite it? Using your notes. Something on top and something on bottom. You're good, Private. Show me.
Oh, wait.
Ooh, I like it. I like it. Anybody else? I like it. The 2. Missing some things. We're close. Okay, there we go. The 2 was supposed to go up top. What was supposed to go down bottom? The 3. Now, just a few of you made it a little bit harder than it needed to be. Can I show you another way of doing it? Hey, guys. I really don't want to hold you late. Okay, there's an or. Some of you rewrote it, and you rewrote it as 25 instead of 5 squared, which wasn't wrong. But what would have been the understood exponent for 25? The understood exponent? Just 1, right? So if you had done 25, it would have been 25 to the 1/3. But why is this one probably a little bit better? Because this one is breaking it down into its factors. What if I was to ask you to rewrite instead 4 to the 2/5, going the other direction? How would you guys go the other direction? What if you weren't going to the rational exponents, but you were going to the radical? 4 to the 2/5. Does anybody know what should go under the radical? The big number should be a? The big number? The base? The 2's on the inside and the 5's on the outside. I saw a couple of you did it right. Go ahead and erase your boards because the class is about to end.
No, I did it.
Hey guys, good. Take your notes home. Notes are supposed to help. I want you guys just to do numbers 1 through 10. Just numbers 1 through 10. Let's come back on Monday. We'll go over homework questions on Monday and go a little bit further into section 6.2. I'll take the expo and do the whiteboard on the way out. Just 1 through 10. Take a picture of it. Or write it down. Bye, guys. I'll take it, or you can put it back at the front, but I can take it. You can put it in the front, or I can take it.
I covered my phone. I mean, it's medium. If you didn't study it. Look at that, I'm going to take it. So
yeah, you almost have it. It just got a little messed up.
Oh, and then also, it said page 303, 322. I know the intent. But then I remember you said this was
Yeah, I got a little off with us slowing down this week, so Red Lab will be all nice and up to date for next week.
Do I have the same class?
I know.
He likes it on max power right next to my face. Yeah.
I